How do I interpret, evaluate, and graph piecewise functions? So you've already learned about piecewise functions. If you've learned about absolute value functions, that's a special form of them. And we'll see a little bit, but we're going to talk specifically about just general piecewise functions and look also at another special type called step functions. So a piecewise function is just basically where you have different functions over different domains. So it still has to pass your vertical line test, but you can see like this one has is like goes here, and this one just changes. And this one goes, so how do you define these? Well, there's not like one function. It's not like f of x equals x plus 2, and you're like, oh, this is it, right? No. What it is over different domains, you have different functions. And we'll get into that here in a minute, but I do want to talk to you about the step function. That's basically where you have just like, hey, from x is -2 to 1, it's this. Then here it's this. And it just basically kind of looks like steps going up over the course of that. Whereas this is not a step function because it's not all constants. Basically, if f of x is equal to a constant over a certain domain of x, like this is, where you have a bunch of horizontal line segments, then you're looking at a step function. If you don't, like this says a different type of line segment there, then it's just a piecewise function. And also the circles are going to be critical here. Not included versus included. If it's filled in, it's included in that domain. If it's circled, it's not. So like normally you'd say a horizontal line would go up through here, right? And across both of these points. But because this top one was not included, it doesn't actually go through there. Now, how do we write a piecewise function? So I started this one out, and f of x, and you put this little brace here, is equal to 1 when x is greater than or equal to -4. So here's -4. It's a filled in circle. X is greater than or equal to that or less than -2. Notice that that's not included, and that's why it's an open circle. F of x equals -x plus 1 when -2 is less than or equal to x. So this is where the -2 is included. Goes all the way down, or an x is greater than or equal to 0, or just greater than 0, and then 0 is an open circle. I didn't fill in this last one, so I'm trying to explain to you how to do that. So this last line segment appears to be f of x equals -1, 2. So you would just write -2. It's a constant value here. And you put a comma. And now you would say it's from, so this is a filled in circle at 0. So 0 is less than or equal to x. And it actually also has a filled in circle here, 1, 2, 3, 4. And so x would be less than or equal to 4. If this was an empty circle, then it would not be included. You just have a less than symbol there. And that's how you would interpret or kind of write from a graph into your piecewise function. This is what it would look like written out. Some more evaluating and graphing, right? Interpret and evaluate graphing. So here we have this piecewise function. F of x equals x minus 3 when x is greater than 3. F of x equals -x plus 3 when x is greater than 3. All right, well, what's the value of f of 2? So for this, I can just look up here. 2 is less than 3, so I substitute it in. 2 minus 3 is -1. All right, the value of f of 4. Well, 4 is greater than or equal to 3, so I do 4, -4, plus 3 is -1. So they coincidentally both have the same output here. You could plot these points, and that could be part of our graph. So if I go 2, -1, I go over 2, down 1, right? I go over 4, down 1. 1, 2, 3, 4, down 1. All right. Now, I can also just graph these lines and only graph them when x is less than 3. So in this case, x is less than 3, so when x is 0, it's going to go down to -3. Now I have 2 points for this section, so I simply can draw this straight line here. and it's going to go all the way. My slope is 1, so actually we just go up 1 over 1. So here, right? Goes all the way to here. And this is probably going to look like an absolute value function now that I think about it. In this one, my slope is -1, so I can start at this point, and I can go rise over run. So my rise is down 1 over 1. So I put a second point, and I'm going to continue this all the way to this here. Now, interestingly enough, this point here would be an open circle for this top one and a filled in circle for the bottom, and they actually intersect at that point. When x is equal to 1, 2, 3, the two lines intersect. These two lines intersect on this graph. 3, -3 plus 3 is 0, 3 minus 3 is 0. So they both would be at 3, 0. That is intersection. This looks like the vertex of an absolute value function. Again, this is a potential. You can write absolute value functions as piecewise functions. It's another way to write them. I didn't want to iterate that example. Sometimes we have just values, substitute back in. I've shown you how to graph this using your slopes, finding other coordinates like your y-intercept, things like that. So how do I interpret, evaluate, and graph piecewise functions?